Welcome to part 2 of the series of graph in Java. We are still working on this graph here. We just made, in part 1, we made the graph and the edge class, and now we're going to make a breadth first iterator class, which will visit all these vertices one by one. So stay with me here. Okay, so we'll make a new class here called breadth first search, like that. And breadth first means that it actually will visit the vertices. Let's say if we start in A, then it will visit first A's neighbors, which are D and B, and only then will it expand either D or B and then go to C. The opposite would be depth first search, which would go from A to B and then to C. So we will take breadth first in this case. Okay, so we will in this class have a reference to the graph itself, and as we are so clever as making it generic, we will need to have the t parameter included at the top, and a reference to the graph, which has a t also. Graph equals null. And now comes the most trickiest part here. We need to keep track of the vertices that we have been visited, so we don't visit them yet one more time. And one way of doing this is to have a map, a hash map, that keeps track of all the vertices we have been visited. And this hash map could be made like this, hash map, and the key would then be of type t, because that will be the whatever kind of object we use for this collection, and the value will be of type integer, which will be just a counter which counts increments each time. So, and we should call this mark map. So yeah, and we will make it a new hash map, and we don't need this in front there. Okay, and then we need a counter, int counter, or what's it called, the order visited, yeah, order visited, which will just be incremented by 1. So every time we go to a new vertex, we will increment this one, and then we will see the ordering when we are finished. Okay, so we need to have a constructor to set this graph. So public bfs, and we'll give it a graph as an argument. Should have the t here also. Graph g, we'll just say graph equals g. Yeah, and now we need to make this one and only single method that will traverse the entire graph, giving only a starting point, which will be a vertex. So we'll make it a public void traverse graph, and it should have a vertex of type t as everything else. So we call it first vertex, first vertex. And in order to figure out which vertex to visit next, we will need some kind of a queue. Okay? And this queue could be of type linked list, so let's use that one. It's nice and easy. So it should be of type t as everything else. We call the queue equals new linked list of t. Yes. Yeah. And the first thing we could do was just to add this first vertex to the queue. We can say add first vertex, this one. Okay, so now we'll have to do some kind of a loop. We will need to loop for as many times as there are unique vertices. And we'll make a while loop here. And I'm going to say for as long as the queue is not empty, okay? Queue is empty. So while it's not empty, then we can proceed. So the first we will take this first element from the queue. We can call it visiting vertex. Visit vertex, make that shorter. Visit vertex, which is the current vertex that we now examine, equals queue remove. Yeah. And we need to figure out whether or not this particular vertex has been visited before. And that's where this mark map comes in. Okay, so we can ask if it's not been visited before, then we should visit it now. Okay, so if not mark map contains visit vertex as a key, then we know it's the first time. So it is the first time we visit visit vertex. Yeah? Okay, so the first to do now is to say, actually, yeah, now we have visited it, so we will make sure that mark map register this by saying put the key will be visit vertex, yeah, not to confuse with this one, because this was just the very first one. This will be whatever is in the queue. Yeah, the value will be this order visited, as I have defined here. And this should be incremented each time, so we'll just say a plus plus at the end. So now we need to check out all the neighbors of this particular vertex, as it is a breadth first search. So how do we get all the neighbors? That's the most tricky part of this algorithm. Yes, okay, we can find all the neighbors by going to the graph and asking for the adjacency map, and then we can ask for this inner map, which we can get by saying get the key, and the key will then be this called visit vertex. Yeah. So now we have, this is the outer map, right? Outer map. And when we call the get on the outer map, we get the inner map for the key of visit vertex. Yeah. And what we now want is all the keys for the inner map, and we can just by calling this key set here. So this key set returns all keys in the inner map when we first asked for it by giving the visit vertex as a key for the outer map. So keep this, stay with me here. Okay, so that will be, say for example, if the first vertex would be A in this example, then this key set would return actually two entries, one where the key is B and the value is 4, and the other one where the key is D and the value is 5. Okay, so this practically contains all the neighbor vertices, neighbor to this visit vertex. Okay, so we now just need to make a loop that loops around these however many neighbors there are. So we say for, and there's going to be a T called neighbor in graph, and we get this map and then get the key set. So now we have all the neighbors, but since it might be that case that we have visited the neighbor before, we need to check again. So we need to say if not mark map contains key neighbor. If it does not contain it, we know it's the first time we visit. Or I would say we know that we have not yet visited this particular vertex. So we need to add it to the queue. So we'll say queue here, add neighbor. And that's it. Now this will just loop around for as many times as there are elements in this queue. Okay, so now let's go and try this code. So we'll make a new class, which we will call use graph. This will have a static method, and we'll make a new graph here. And now we need to actually assign a type, and that will be point, one of Java classes, point there. Graph equals new graph of point, like this. And now we need to make these 4 different vertices that I have here. So maybe we can zoom out a little bit. This one, yeah, can zoom it in. Okay, so I'm basically just going to make 4 vertices, A, B, C, and D, and give them the coordinates that are, 0.0, 0.1, and 1.1, and so on. Yeah, so we'll say point A equals new point of 0.1, and 1, 2, 3 more, so in B, C, and D, and the B will then be 1.1, the C will be 2.0, the D will then be 0.0. Okay, so now I have the 4 entries. Now there's left to make the 5 different edges, yeah? And they will link these 4 different vertices. So we'll say edge of point, and we'll call it AB, the first one, equals new edge, and here we will give it A as the first one, and B as the last one. Sorry, B here, last one. And then the weight was 4. Okay, you can see it. You can see it there. The weight is 4 from A to B. And I'm just gonna make the 4 other edges just as this one. Okay, just the same. So 1, 2, 3, 4. The other one will be then A to D. Will be A to D, and that will be 5. And then D to C should be E to C should be 6. And then we have D to B, which will be D to B, which will be 1. And then B to C, which will be 2. B to C should be 2. Yeah. Okay, so now we need to add these 5 edges to the graph. So by saying graph add edge AB, and we can make this AD, DC, DB, and BC. Yeah. So now we have produced the graph completely, and now we can make an object of this breadth first search. BFS of type point, and BFS equals new BFS of type point, and the graph should be given as an argument. Yeah. And now we just call BFS dot traverse, and we can start by giving it an A vertex. Finally, we could just make some kind of a print outline where whenever we visit a new vertex, and we can do it like this, so we can say visit, we visited which one, it was visit vertex, this one, and it will just call the toString method, which should give the point x and y coordinates, plus, and order, give us the order visited. Yeah. Okay, so let's run this use graph, and as you can see that 0.1 is the first vertex visited, also called A. Then we go to 0.0, which is D. Then we go to 1.1, which is B. And this should be correct, right? We should go last to C, because it's a breadth first. And we go last to C. Thank you very much.